Hello everyone, I am Begüm. I will respectively explain what is concrete, how it is made and manufactured, what are some traditional usage of concrete, what are some innovations of concrete, and finally, I will show you some good and different examples of concrete. Concrete is a composite material composed of fine and coarse aggregate bonded together with a fluid cement paste that hardens over time. Concrete is the second most used substance in the world after water and is the most widely used building material. Its usage worldwide, ton for ton, is twice that of steel, wood, plastic, and aluminium combined. Concrete is everywhere in our lives. Ingredients of concrete are water, sand, gravel, and finally, cement. Manufacturing process. Batching of concrete is the method of estimating and mixing the required concrete ingredients with both weight or volume according to the mix design and transplanting them into the mix to create a consistent quality of concrete. Concrete mixing is a process of mixing the ingredients of concrete, such as cement, sand, aggregate, water and mixture together to make concrete of suitable grade. Transportation of concrete is a method of moving fresh concrete from mixing plant to the place, probably where it needs to be deposited in the structural element. Concrete placement is an important process in the construction that determines the success of the structure and its life. Technical and environmental conditions are taken into consideration while placing the concrete. Compacting of concrete is the process that expels air and trapped air from freshly placed concrete and packs together the aggregate particles to increase the density of the concrete. Curing is the process of maintaining the most dry of freshly placed concrete to complete the hydration process and to ensure proper hardening, attaining strength and durability. Concrete finishing is a process that strives to create a smooth, durable surface. When finishing concrete, thimming is crucial and you must pay close attention to the condition of the concrete. Traditional concrete usage. Cast-in-situ concrete is prepared, placed and finished on the construction site. Another name of cast-in-situ concrete is poured-in-place concrete. Generally, concrete slabs, concrete foundations, beam, column, wall, roof, and etc. are preferred constructions in cast-in-situ concrete. Precast concrete is a construction product produced by casting concrete in a reusable mold or form, which is then cured in a controlled environment, transported to the construction site, and maneuvered into place. Examples include precast beams and wall panels for tilt-up construction. In contrast, cast-in-situ concrete is poured into site-specific forms and cured on-site. 5 innovations of concrete. Simply put, 3D printed concrete is a special mix of concrete, specifically prepared to flow with ease through the nozzle of the printing equipment. The structures built with 3D printed concrete are created on the fundamentals of layering, with each layer deposited on a previous layer of pumped concrete. This technique is repeated until the preferred structure emerges, eliminating the need for casting concrete into molds or frameworks. 3DCP is a cost-effective building method. The curing time of such concrete can be as low as 3 days, and complete structures can be constructed within hours, making it a relatively quicker and cheaper alternative to conventional construction methods. The ingredients of the concrete mix are similar to those found in other concrete mixtures: water, cement, and aggregates like sand or stone. The success of the recipe lies in the texture and consistency itself. A workable consistency lowers the chance of pressure buildup that can block the nozzle or damage the printing equipment. Hence, for building purposes, the consistency is kept similar to that of aerated dough. Self-healing concrete is an amazing invention in the building construction industry. Its use can solve the problem of deterioration well before the end of their service life. Conventional concrete has a flaw: it tends to crack when subjected to tension. In self-healing concrete is prepared with mixing healing agent or bacteria in the concrete convert nutrients into limestone has been under development at the Civil Engineering and Geosciences faculty in Delft since 2006. This research work has a wider perspective or goal to study the self-healing properties of plastics, polymers, composites, asphalts, and metals as well as concrete. Ceratec has developed a process that consumes olivine and waste carbon dioxide from flue gases and produces two products which both have significant value in construction. Silica is produced, which can be used as a supplementary cementitious material in concrete, meaning the amount of Portland cement in the concrete can be reduced by up to 40%. As the silica comes from a process that captures carbon dioxide, it is carbon negative and the concrete can become carbon neutral. Magnesium carbonate is produced that can be used to make a range of zero carbon construction materials and consumers' products, including alternatives to building blocks and plasterboard. The aim is for humanity to be able to continue building robust cities and infrastructure, but without the climate cost of traditional cement mixes, and with the Ceratec technology, this goal is achievable. Pervious concrete is a special type of concrete with a high porosity used for concrete flatwork applications that allows water from precipitation and other sources to pass directly through, thereby reducing the runoff from a site and allowing groundwater recharge. It is made using large aggregates with little to no fine aggregates. The concrete paste then coats the aggregates and allows water to pass through the concrete slab. Pervious concrete is traditionally used in parking areas, residential streets, pedestrian walkways, and greenhouses. I hope we can better understand the value of some materials these days when we are struggling with floods. A new type of fiber-reinforced bendable concrete is used in various places. Traditional concrete is a very brittle material. Any buckling or bending will cause it to crack. A new type of fiber-reinforced bendable concrete might just be putting an end to that issue. This new concrete around 500 times more resistant to cracking than regular concrete thanks to the fibers, which account for 2 cracking than regular concrete thanks to the tiny fibers. The fibers slide within the concrete when bending occurs, providing it with enough give to prevent breakage, capable of exhibiting considerably enhanced flexibility. Different examples of concrete. Who said concrete is not aesthetic? Let's break the traditional rules. Thanks for watching.